Alrighty, today we're going to kind of close the battle loop and get out of the battle, so we'll actually be able to repeat the process. Doesn't mean it's the last tutorial on this, but this will kind of get the main objective out of the way where we can have the full battle workflow. So this is a diagram to kind of help through this because it does get confusing. First thing to note is the overworld scene I'm storing in a variable in my global script. The reason for that, let me go over to the overworld, is I'm being lazy with this. I loaded that sprite, the whole overworld, as one gigantic sprite, which is already upscaled 4x, which is, about the maximum size sprite you can have in Godot. So that takes like 5 seconds to load or so. And if you try to go into a battle and then come back from the battle and load this scene again, the end of the battle just freezes up while it's trying to load all that into memory. And that's no good. So even though it's from my lazy practices in this case, it's a valid scenario, which is good instruction for how you might handle this situation. So again, in the global script, I have a variable to hold that, which is here. So the variable is defined at the top right here. It's just a node. And when you load the scene, it returns it as a node when you instantiate it. So this is a constructor. So if you're not familiar with constructors, it's C#'s version of the ready method, basically. When you have a class, which the class name is globals right here, and then you have a method with the same name, that will act as a constructor. It'll run as soon as the class exists. So I'll come back to these battle states and why I did that, but the main thing here is this overworld scene. So this way it'll be accessible and already in memory when I return from the battle. So moving on, when the battle starts, it's going to be controlled from this encounter controller script I have. It does the camera and sprite stuff. It adds the battle scene to the scene tree, which will then subsequently add the characters and subscribe to events. A word on the events, that's another gotcha. The hand cursor and the battle scene talk to each other, so I, in somewhat disorganized fashion, had them subscribe to each other's events. So it does that, and then it removes the character, in this case Locke, of course, the lead character from the scene tree, and then removes the overworld scene itself. So this is a key difference. There's a difference between removing it from the scene tree and removing it entirely from memory as well. This is just going to be like remove child is the command that's going to happen here. And then it's still going to be in a variable here, which does take the memory, but then it'll be easily accessible when I end the battle. So when the battle ends, this is where the gotcha comes into play. I have to unsubscribe whatever events I subscribe to, because if I don't, and I subscribe when the battle starts over here, it'll happen twice is a simple way to say it. So I'm going to go through that in the code, but I'm going to unsubscribe from the events, and then we're going to add the overworld scene back to the tree. It's going to come from over here, the global's variable. You're going to basically add child to the root of the scene. And since it's coming from memory, it'll be nice and fast. And then remove the battle script, which is itself. So let's go through this in a more code fashion. We've got the game root scene I created because before I just had the overworld be the main scene, so when I hit play, that's what it started with. The problem with that in this case is if I want to store it in memory here and have it as the main scene, they won't be the same instance. It'll be like having a separate copy of it. So using that constructor, I've loaded the variable here. And the game root is just a scene with nothing but that script. This is all that is. And I've set this as the main scene. So the script, this is what the vanilla command would look like. It's just add child, it does the command. But like I said, that scene takes a good 5 seconds for the global script to load this in here. So if I do this, it's going to try and do it before this is loaded. That's no good. So that's where call deferred comes in. What this does is it waits for idle time, which will by definition be after it's loaded. You just specify the method and then the arguments to the method, so it's the same exact thing as this except deferred. Now the reason for this snake case here, this underscore nonsense, this is an irritation that I've mentioned before with Godot's C# implementation. So you'll see here I have the typical Pascal case version of the method, just capital A, capital C, add child. So the reason you can't put it in here this way is because it's passed as a string. Godot has a bunch of functions where you actually pass a function as a string, which is unfortunate. It only recognizes the GD script version of that. If you're trying to do C#, anytime you're passing a function as a string, that tripwire has to be stepped over. So I wish that were all there is to it. Unfortunately, not so much. So the overworld script over here, I have moved the code into this initialize method. This is mostly the same that was going in the ready method before. I did add a couple variables that I'll get into. So the global's entered battle position is just going to store the location of the sprite when we start the battle. And the returning from battle, we're just going to set that when we're exiting the battle. That way, when we're exiting the battle, we want the sprite to be set to that position instead of just wherever the last town or whatever we came out of. And otherwise, we'll go to the spawn object, which we can control, and set the character's position to that position. So since we've handled the conditions here, one might ask, why not just have that be the ready method and leave it at that? So the problem here is this ready method, you can connect whatever to it. It only runs when the scene is first created. So since we're storing it in memory, when we pop it off the tree but keep it in memory and then add it back in, the ready method does not run again. So that's why it needs to be connected to a different method. So the next logical thought might be, okay, we'll just run this whether we're starting the scene for the first time or whether we're returning from battle, then this if block down here should cover the scenarios. Also a problem. And it's a problem because of this spawn object here. So the ready method implies all the objects are, well, ready and in the scene. And that's the case here. So it's basically another race condition that can come up. So if we just try to run this initialize stuff when the scene enters the tree, which is kind of what I'm doing here, but not quite, then that first time it loads, it will get added to the tree before all of the objects are ready. So if that happens on the first attempt, it tries to do this and the spawn object isn't ready yet, and it spawns the character at the 0, point of the overworld sprite. So enter the hack. I do need the ready method to run the first time, but subsequent times, no. So what I'm doing here is I just started off with this ready completed. It starts off as false. So when the ready method runs, it sets it to true and then runs the code. Now, in order to avoid duplication, I have this reinitialize method, which will only run the initialize code if ready is completed. And this is the method that's going to get called when it gets added to the scene tree. So really this mess is about getting around all the issues that come up from the first time the scene loads and wanting to keep it in memory. So this ready completed check, if I don't have that, I pretend that's not there, what will happen is on the first load, this is going to run because it is being added to the tree, right? And the ready method's going to run because it's the first time. So if we don't have that check, it actually loads the scene twice. So this is all designed to run the ready method on the first try and not run the reinitialize on the first time. So here's the actual code for Encounter Controller, which I've gone through before, but I'm going to go through the changes to it. So one of the main changes is down here. I have the characters that I got up here. Just gets all the characters in the group characters. So now when I call this load battle scene method right down below here, I'm also passing in the characters. Like right now it just does the lead character. I just made this extensible so that if you wanted to actually display multiple characters on the overworld, you could, and it loops through them. So what this is doing is actually removing lock, in this case, from the overworld scene. That's what I was talking about right here. So because I'm storing this in memory, then I add lock to it when we first start the game. If I pop it off of the scene tree, that doesn't remove lock. So if I come back and call the same code again, that's what I was talking about before. It'll add 2 locks and then we'll have a mess. So that removes the character, and then we remove the overworld scene. And this, so instead of like, Godot also has change scene to file or to packed, I think. So this method, if you were to pass a scene into here, it would actually completely unload the scene you're currently in, and that takes it out of memory. So since we don't want that, we're just removing it from the root, and that's the difference. It's just your entire scene is just adding or removing a child. So one of the things that was added was a rudimentary this. So at the end of the battle you show your experience. I just did experience the weapon from the Rhinotaur and the GP. So this is hidden obviously, but this is in here. So in order to store the text that's going to appear there, we have some variables here. This victory text sprite and victory text label. Those are just going to get those nodes here and here, and it's going to store them so we can access them easily at the end of the battle. Another one is this battle 1 text index. So what I end up doing at the end of the battle is storing each actual message that's going to appear up at the top there in a list of strings. this is going to keep track of which ones we display because, as in the original, you press the A button or whatever, and it moves to the next message and then finally exits the battle. This will keep track of our progress through that list of strings, and then the last one will get us out of there. So let's look at populating those text lists. This is after an enemy gets hit, remember. So here's where we got to last time, where we removed the enemy if we killed it. So now we're going to do a check within that same code block for the count of enemies that have HP greater than 0. And if we have less than or equal to 0, then we've gotten all the enemies. So that means we won the battle. So here we change the battle state to battle 1, get rid of the icon above the head, and we're going to create another tween, which at the end of this tween here, you'll see I'm delaying it 2 seconds. When I was testing, that did seem to run at the same time as this tween. So I made that however much more I wanted, just another second in this case. So we're going to get the battle theme and stop it. We're going to start the fanfare music, and we're going to need this a little lower down here. I'll explain that. We're going to get unwounded characters into its own list so we can get the count on here. That's why. But before we use that, I'm going to iterate over each character where the HP is greater than 0. And I'm sure the first thing to wonder is, okay, why not just put unwounded characters in here, and instead I'm doing this whole expression again? The reason is I want to keep the index. Remember, we have the characters list, which is the list of the database object that has the stats, and then we're going to use that to get the corresponding node 2D for that character. Since those lists share the indices, I don't want to use this because it'll be a new list with different indices potentially if we have wounded characters. So this is going to do just that. It's going to find the index of the character that we're on in this loop right here, and then we're going to get the corresponding node, and then get that node's battle animation player, queue up the spin and the fanfare animation, then they'll do their little dance. So now we've got that text to put at the top of the screen. This is going to get the experience from the enemies from, again, those database objects. We're going to iterate over the enemies, and just every enemy we're going to add to this experience variable so we get a final number for experience. And now this is where we need how many unwounded characters we have, because the experience gets distributed to the unwounded characters, so we want to divide the number we're showing at the top by however many of those characters, and then just put that number into a list. This is going to be the list that stores each message at the top of the screen. And come to think of it, I didn't store it in the database here. So this is a good opportunity actually to show like how you would add a trait in there in the NoSQL schema. So I'm going to bring up LightDB Studio here with the character table or collection. And you'll see here, I don't think I actually have experience as a column. Right, so what's feeding that from way back when is this character class. When we add an item to the LightDB database, like this determines the columns and traits or whatever it has. So what I'm going to do is just add one. Prop and tab twice is just tab once rather is a shortcut to add a property to a class. So that's what I did there. Int, and then I'm just going to do experience. I'm going to save that, and then I can actually have a case where I want to loop over the unwounded characters because they're the ones going to get the experience. So if you do for each character in the unwounded characters. So remember, this experience variable now has the number that's going to go to each character, and that's what usually gets displayed on the screen as well. So we're going to use that as what we increment here. So we're just going to say character.experience, and that shows up because I just added it to that class. Just going to do plus equals exp, and then we need to update the database, and that's the method that already exists there. That should do it. Items are a little more involved just because you can have more than one of the same item, which is annoying. So this is the list I'm going to store the item and how many of them we get. In this particular example, it's not going to be more than one, but to have the functionality there. So the enemy has the dropped items attribute in the database, and that is stored as a dictionary for string and float, and that's because we want the float to be the probability of getting that item. So we have a random number generator. This is the C# method again. The random without any arguments passed in is already going to be between 0 and 1. And then just taking that object and getting the next double, that'll give me a double between 0 and 1 again. Item probability, of course, is going to be the float value here. So just to clarify, in C#, the dictionary, if we have the object here because we're iterating over it, the key is going to be the string, and the value is going to be the float. Typically you just pass in the string and get the float back, or you're looking it up in the dictionary. That's kind of the logic. So this was just debugging. And we're going to say, so if the trigger value, so if I'm between 0 and 1, I'm testing if that's less than or equal to 0.875 or 87.5%, and that's going to drop the item in that case. So we want to update the database. In the database, I have the collection just has a column for inventory count. And just as a refresher on the UI, if we go into the item list, it just shows any items that have a greater inventory count than 0. Either way, this will update that to one more right here. It'll go to the item collection and find one that matches the item's name. Remember, the key is the string here. And it's going to take that object and add one to its inventory count. And in the database handler, we're going to do update item and pass in that object. So it's going to update it with that new data. In the database handler, I did just add update item here, which is exactly the same as the update character, except it's using the item collection instead of the character collection. So this is the part we're going to handle the possibility of having more than one of the same type of item. So this item list, again, the one we're storing them in here, if that contains the item that we're iterating over, we're going to add one to the value here. Otherwise, we're just going to add the item and however many, one, because it's the first time. So that will give us this item list with the items and how many of them. So again, for this example, just one. For each of those items, we're going to add this text, which is going to be displayed for each item. So got the item name times whatever the item value is, so 1 or 2 or 3, whatever. GP is very simple, just like experience. You're going to start with 0, iterate over each enemy, and the database object has GIL, which you can see I'm very consistent. We're going to store that in GP, and then we're going to add this message that we're displaying at the end, so got however much GP. So at the end of that here, now we're going to make that sprite visible. This one here again, we're going to make that visible, and it's got, you'll see the labels in here, so that's what we're going to set as we go through those text list objects. So because the player is going to be able to press the A button or whatever submit button in order to go through those lists however fast they want to read it, we're basically controlling the loop manually. So right here, we're going to set it to the first item in that victory text list right here. So we're going to start with index 0, of course, and this is that variable we were storing up near the top. We're going to add one to that battle1 text index. So we're starting the first item of the loop right here, and then we're going to wait for input. So because it's input, we're going to have to handle it up in the process method. So here's back to process, and I just check for if the battle state is 1 right here. So here we're just checking if the button is pressed. If the button is pressed, we just compare, okay, has the battle1 index reached the victory text list count? And if it has, that means we've gone through all of those messages that they're going to see, and then we're going to change the battle state to battle end. The reason I'm differentiating between battle 1 and battle end is because if you wanted to do like a fade out effect afterwards, then we want to make sure we do only what we want in the process method. So down here it just returns for now. I was lazy, I didn't do the fade out, but this is just set up so that you could add that in. And then this end battle method is right above here. Get there in a second. So otherwise, if we're not through the victory text list, obviously we're just going to set the text to the victory text list at this index and then increment the index. So basically we're just manually stepping through that list. So if we do have the battle end, here it goes, end battle, we're going to go up here. Overworld input enabled is true. That's the thing that stops us from walking around the screen in the battle screen because we're using the same scene for the characters. Set in battle to false. This is a little gratuitous. I probably should just be the battle states. Returning from battle is true. This variable is just added, again, the one I discussed earlier, to handle the whole overworld and memory headache. We're going to unsubscribe to those events. So again, we're over in this stage here, unsubscribe to events so that we don't have them fire twice next time we get into a battle. And here we're going to add the overworld scene from the memory in the global script back onto the tree. Encounter controller, reset encounter. What that is we're just resetting these variables which track when they should trigger another battle. Because if we just leave them, they're going to take one step and be in a battle, and that won't be fun. And then this queue free, so the battle controller is attached to the battle scene. So this is going to free the battle scene, and then we're good. We've added the overworld, we've removed the battle. Closing this loop, of course, I've found out all the mistakes I made before. So one thing we need to do is make sure we clear out or reset any variables that we're using in here, like all these object lists. Just clear them, because whenever you start a battle, they're going to get populated in the battles ready method. The index, of course, and just these variables we were using before. Another small addition I made in the process method right after this end battle stuff is right here. This being, whether it's in active or wait battle mode, I don't want the timer bars to increment if we're in wait. So this is going to come back to that constructor I made in globals here at the bottom. So because those wait states are basically a Venn diagram of the states already created in here, so like selecting objects, selecting menu states, selecting enemies, any of those selecting states, we do not want to increment the timer bar. We've got the variable defined right here, and we're going to populate the variable in the constructor. So add range, these are lists. Again, we're going to add range and we're going to add a list to the list. Add range, you can put multiple items in there, so that way we can add one of the other lists. So selecting objects, menu states, and here's an exception, of course. So the main fight menu where you've got fight, magic, whatever item, that one you are incrementing the timer bar. So we're just going to remove that one and then leave all the other menu states. And then we're going to add the enemy selecting states, of course. Battle won, lost, and if there's an action going on, those are the times I'm not incrementing the timer bar. And you can customize it any way you want, of course. So a couple other code additions from the previous tutorials I want to point out. So right here, this I probably should have done right after you select an enemy to attack, or a character if you want. Makes the fight menu invisible and the hand cursor invisible because, of course, you can't select. You've made your choice. Another one I added was right down here. So before I killed the enemy last time, but I didn't remove their name from the list on the left side of the battle screen. So this is going to take care of that. So the enemy menu container get children is going to be every enemy label. And we're just going to look and see if we match the name as we loop through there. And if we do match the name, then we're going to just queue free that label and then break and get out of it. So like if we had more than one of the same enemy, this should just exit the loop after getting rid of one of them. So another fun scenario I found out was in this damage health text. So this one harkens back, so we make the damage appear as a child of the enemy or the character. This is all the same except for this little bit down here. The only change is this if is instance valid. That's a handy check Godot has built in. So the reason we need to do this is because, yes, another race condition. So I would get an error. It wouldn't actually crash the game or anything, but it should be fixed. So when you kill the Rhinotaur and you do queue free on the Rhinotaur, it gets rid of the Rhinotaur and all of its children. So with this delay of 1 second, what would happen is that last hit, it would populate the damage text. The damage text is hanging around for a second and then queue free. But the Rhinotaur and all of its children, including the damage text, would already have been freed by the death of the enemy method there. So this would throw an error because it was already gone. So this is a good check in situations like this. We're going to check is instance valid, this and this being the damage text, recall. We're going to queue free it only in that case, and then that gets out of that problem. So now I want to show where we're actually storing that sprite location when we're going into the battle. It's just right here. So here I defined the sprite variable up here instead of just in here because now I want to access it outside of this loop. So all this does is that globals variable I added, entered battle position. We're going to set it to the sprite position here in the encounter controller script. And down here again, we're passing in the characters to this load battle scene. So that way we can loop through them and remove them. Now the hand cursor is another one I want to grab because, again, we need to unsubscribe to the hand cursor's events. We've shown the battle scene events. Now we need to do this piece. So if we open up the hand cursor scene right here, what I've done is right here, the tree exiting. This will always fire before a node actually gets freed from the tree. So I'm going to disconnect this just so I can show the process. So the tree exiting, you just pick a method. And I made one for tree exiting here. So that connects it right here. And this is where we unsubscribe from those events. It's that simple. So this gets called whenever it's about to get popped off of the tree. And then this will unsubscribe to the events that we subscribe to up here. One thing to remember is that whenever you're in the Godot editor and you're going in here to add something, make sure that you build the project first. So if you had just written this method, you need to have it built or it won't show up there in the options to pick. And that should about do it. So let's actually get this going here. This is going to start to look very familiar. All right, I'm going to go through this usual exciting process. See the menu is disappearing there. Yeah, that's what I said. I probably should have just done it right there instead. Whatever. And you'll also notice the status is down here. That's because I have the invisible victory text box above it. Actually makes it a little easier to see, which is nice. Here we go. So then we got the potion ×1 and 186 GP. So I'm going to press this. It's going to be instant. That kind of sucks. I didn't, like I said, I was too lazy to do the fade out, but it could be done with that battle end status. Let's do one more, just to prove the loop works. And this is where all those lists that got cleared out, it matters. It was starting to cause problems, duplicated scenes. Should have upped the damage. Battle 1, hoorah. And we're back. That'll do it.